I'm Laura Hopewell. Welcome to Standard Deviant School Basic Math. Today's program is adding and subtracting fractions. As you can guess, we'll show you how to add and subtract fractions.
We'll start off with the key to adding and subtracting fractions, finding a common denominator. Next, we'll show you how to add and subtract fractions that already have common denominators. These fractions are already buddies with each other. Fractions with different denominators aren't as friendly, but we'll show you how to make them get along.
So, now we're going to add and subtract some fractions. But before we do, we got to check the denominators. We got to take one important step if the denominators or the bottom numbers of the fractions are different. We'll look at fractions with common denominators first.
Okay, so let's say one pot of coffee has 6 equal cups of coffee in it. Okay, now I'll drink 2. What fraction of my original 6 cups of coffee is left now? I don't know. Somebody tell me, please.
Before we can figure out what fraction is left, we must first figure out how much he drank. He started with 6 cups of coffee, and those 6 cups made up the whole, or 1 pot of coffee. So the fraction for that is 6/6, or 6 cups of coffee out of 6. The amount of cups present were the same as the whole.
Each cup equals 1 cup of the whole, or represents 1/6 of the total amount of coffee he began with. So if he drinks 2 cups, we combine them by adding 1/6 and 1/6. Notice that both denominators are 6. That makes things easy.
When we have the same denominators like we do here, we just add the numerators together. We'll get to problems with different denominators in a second, so you'll have to hold your horses.
To add these fractions with common denominators, just add the numerators and leave the denominator alone. He can be a little grumpy at times. 1/6 plus 1/6 equals 2/6. So he drank 2/6. Or if we reduce this fraction by dividing each part of the fraction by 2, 1/3 of the pot of coffee is gone.
Well, how much is left then?
To figure out how much is left, we need to subtract what has been taken from what was originally there. So we subtract what was taken, 2/6, or 2 cups of coffee, from the whole, 6/6, which represents the original 6 cups of coffee.
Just like the addition of fractions with common denominators, we subtract fractions with common denominators by subtracting the numerators while leaving the denominator.
So we subtract the numerators. 6 minus 2 equals 4. We leave the denominator, so our answer is 4/6. We could reduce this fraction further by dividing the 4 and 6 by their common factor, 2. Dividing each number by 2 leaves us with a numerator of 2 and a denominator of 3.
Now, if the denominators in the fractions being added or subtracted are different, then we gotta alter them so that they have common denominators. But before we get to that, we've got some more terms for ya.
We've already looked a little bit at factors. Looking at the factors of a number will determine if the number is prime or composite. A prime number is any number whose only factors are 1 and itself, such as 7. We can multiply 1 times 7 to get 7, but that's it.
There's lots of prime numbers. 7, as well as 5, 3, 11, 23, 29, and 31.
The second type of number is a composite number. This is any number that has more factors than just 1 and itself. 6 is a composite number. 6 and 1 are factors of 6. 2 and 3 are also factors of 6, since we can multiply 3 times 2 to get 6.
Don't forget, a prime number's factors are only 1 in itself. A composite number does have factors other than 1 in itself.
Now that you got factors underneath your belt, we'll look at fractions that don't have common denominators.
In order to add or subtract fractions without common denominators, we must find the lowest common denominator for both fractions. We want to make our denominators as low as possible. If the denominators in your problem are prime, then the lowest common denominator is simply the first denominator times the second.
Now, why is this? It's because both numbers are as low as they can get. And what you're looking for is the lowest number that both numbers are factors of. So the lowest common denominator of 3 and 5, both prime numbers, is 15. 3 and 5 are both factors of 15.
All right, we've got one more thing to throw at you.
The lowest common denominator is also 1 times the other when all the denominators are composite and do not have any common factors other than 1, like 8 and 9. Both 8 and 9 are composite numbers. 8 has factors of 1, 2, 4, and 8. 1 times 8 is 8, and 2 times 4 is 8. So each of these numbers can be multiplied by another to get 8. 9 has factors of 1, 3, and 9. But 8 and 9 don't have any common factors besides 1.
So since 8 and 9 are composite and do not have any common factors other than 1, we find the lowest common denominator by multiplying them together. The lowest common denominator then is 72, or 8 times 9.
Sometimes you have denominators that are both composite and have common factors other than 1. Remember, a composite number has factors besides 1 in itself. When this is the case, the lowest common denominator is found by finding the smallest number that both denominators have as factors. Let's say you want to find the common denominator for 4 and 10. We'll start with the larger of the two numbers, in this case, 10.
We're looking for the lowest common denominator possible, so we'll multiply 10 by small numbers first. We start by multiplying 10 times 1. Then we multiply 10 times 2, 10 times 3, and so on, until we find a number that has both 10 and 4 as factors of it.
The first multiple of 10 is 10 times 1, which equals 10. But 4 is not a factor of 10. There's no way to multiply 4 times another whole number to get 10. So we've got to go to the next multiple. 10 times 2 is 20. And from our multiplication tables, we know that 4 is a factor of 20, because 4 times 5 equals 20. So both 4 and 10 are factors of 20.
Remember, you're always looking for the lowest number that each denominator is a factor of. 20 can be divided by both 4 and 10. 20 divided by 4 is 5, and 20 divided by 10 equals 2. 20 is the lowest common denominator for 4 and 10.
Look at these multiples of 10. Notice that if we continue to find multiples of 10, that 40 is also divisible by 4 and 10. But 20 is lower, and you want to keep things as simple as possible in math.
Sure, if you like to do things the easy way.
We're trying to make the denominators in our fractions the same. But we just can't switch the numbers and go on. We have to multiply the numerator and the denominator of each fraction times the number that will make both fractions have the same denominator. Now let's put all this stuff to use and add a couple of fractions.
We'll add these two fractions, 7/12 and 5/18. The first step is to find the lowest common denominator.
We again start with the larger number, 18. We'll find multiples of 18. 1 times 18 is 18. 12 isn't a factor of 18. We can't multiply 12 by any whole number to get 18. So, we keep going. 18 times 2 equals 36. 12 is a factor of 36 because 12 times 3 equals 36.
The smallest number that has both 12 and 18 as factors of it is 36. 12 times 3 equals 36, and 18 times 2 equals 36.
Now that we know the common denominator is 36, we can multiply both parts of each of the fractions to make their denominators the same. Remember,
As long as we multiply the numerator and denominator of a fraction by the same number, the value of the fraction doesn't change.
yes. That enables us to make the denominators of both fractions the same without altering the value of the fractions.
Pretty nifty.
I'm impressed.
It doesn't change.
Let's start with 7/12. 3 times 12 equals 36. We also have to multiply the numerator, 7, by 3. That way, the value of the fraction doesn't change. 7 times 3 is 21. So our first fraction is now 21 over 36. Now the other fraction. The denominator is 18. We multiply 18 by 2 to get 36. We multiply the numerator by 2 also to equal 10 for our numerator. So our fraction is now 10 over 36. Now both of our denominators are the same. We haven't changed the value of either fraction, just altered them so the denominators are the same.
Let's say I like to eat pie, but I can't eat a whole one. So I eat a half, a fourth, or an eighth. And those are all fractions. Those are all fractions. Those are all fractions. Those are all fractions. Those are all fractions.
Okay, we've got common denominators for our fractions. So now that our denominators are the same, we can add or subtract the fractions and then simplify if possible.
We add 2136 and 1036. When adding or subtracting fractions, we add or subtract the numerators and always leave the denominator the same. 10 and 21 equal 31, so our answer is 3136. 31 and 36 have no common factors, so we can't reduce it any further. Our answer is in its simplest form.
We won't do it here, but subtracting fractions is done in the same way as adding.
Let's review.
To add fractions with common denominators like 2/5 and 1/5, just add the numerators and leave the denominators alone. Subtracting works the same way, except instead of adding the numerators, you subtract the numerators. A prime number is any number whose only factors are 1 and itself. 17 is a prime number because its only factors, 1 and 17. A composite number is any number that has more factors than 1 in itself. 6 is a composite number because besides 1 in itself, 6 also has the factors of 2 and 3. Add or subtract fractions with different denominators. Find the lowest common denominator for both fractions. Convert the fractions so they all have the lowest common denominator and add or subtract away.
Our show has come to an end. I'm Laura Hopewell. Thanks for watching Standard Deviant School. See you later.